David, welcome to Talk Satellite, and for you, a new role.
Thank you, Kevin. Appreciate having us on your podcast. Yeah, it is a new role for me. I joined as Chief Strategy Officer for Applied Aerospace here right at the beginning of the year. After 25 years in satellite communications, I decided I wanted to work for somebody who actually built things that fly. So it's been a lot of fun.
So, Applied Aerospace, can you provide background on the company?
Sure. It's a really interesting company. We like to say that we have an undeniable heritage because it was founded back in 1954, so 70-some years ago, building helicopter blades. But today, the company provides all manner of structures, components, and subsystems for really four key market segments. The spacecraft industry, the launch vehicle industry, aircraft, military, fighter, bomber, early warning kind of sensor aircraft, and then also specialized radomes for both ground and naval-based radar and missile defense systems. We're based in Stockton, California, actually about a 10 building, 400,000 square foot facility, multiple buildings, really a campus on about 25 acres. And there we do everything from composite layup with carbon fiber and fiberglass, metal procurement, metal bonding and fabrication, as well as assembly and then test and integration. We also have a facility in White Salmon, Washington, which is kind of just outside of the Portland, Oregon metro area, where we do a lot of innovative composite engineering and really focus on unique geometries and shapes, as well as tube kind of structures, which requires kind of a unique manufacturing technique. And then our newest location is in Huntsville, Alabama, just outside of the Marshall Space Flight Center. And that is our advanced materials and deployable systems division. And there it's a lot of really unique capabilities to support spacecraft. So those are kind of the core elements of the company. We have about 650 employees across all three of those locations.
So how does Applied Aerospace stand out from others in this domain?
Well, if you think a little bit about, what it is that we do, right? If you picture in your mind's eye a satellite, which for most people is there's a box in the middle, which is the bus or the body of the satellite. There are a couple of wings, which are the solar panels that power the satellite off to the sides. And then there are reflectors or other things that are on board the bus of the satellite. And we actually build all of those components. So we build the body, the core structure of the satellite. We build the deployable satellite solar arrays, which have to fold up like origami to fit inside the launch vehicle. And we even build the antenna reflectors, which you see a lot of them here at the show, but the satellite antennas that have to perform in the vacuum of space and an environment where temperatures can change hundreds of degrees in a matter of minutes is really unique engineering problem. So, we leave the propulsion systems and the telemetry and the payload, we leave that to other experts, but we build kind of all of the things that you can see around a spacecraft. In the launch vehicle industry, kind of similarly, if you imagine a vehicle, both crewed and uncrewed vehicles, we're on 6 different medium and heavy lift launch vehicles from all the major manufacturers that you would think of. And so, we start with kind of the nose cone for a crewed spacecraft, a lot of panels and elements of the first and the second stage, wing structures, control surfaces, all the way down to the deployable legs for when the first stage returns to Earth on a concrete pad or on a remote barge somewhere. So kind of from top to bottom of the spacecraft, we provide all of those elements. And then kind of the last segment of our business is really focused on what we call land and sea, which is really specialized radomes, missile defense systems like missile containers and vehicles and those kinds of things for both radar and communication solutions on the ground. It's a fairly broad spectrum of things that we work in, but it all kind of ties back to sort of a core principle of having a balance between the aerospace discipline that is required to be successful in this industry, but also the new space agility. And I guess what I mean by that is we're fortunate enough to have some of the biggest aerospace giants as our customers. In fact, just a couple of weeks ago, we were meeting with Northrop Grumman at their annual Supplier Excellence Award. And for the 3rd year in a row, Applied Aerospace was named one of the top 50 suppliers among like 11,000 suppliers that Northrop Grumman uses. So that was really an honor, but it was also, I think, a testament to the fact that to be successful working for those really large scale aerospace companies, you have to follow their prescribed engineering processes and protocols and quality assurance programs. So there's a real discipline to that. At the same time, our fastest growing market segments are often driven by the new space innovators, the SpaceX's and the Blue Origins and the Astronauses of the world. And those companies really value agility and flexibility and creativity. And I think the real value proposition that we bring for our customers is being able to strike that balance between the discipline that you need and sort of the experience, 70 years of knowledge about what works and what doesn't in a complex manufacturing environment, and help our customers shape their designs in a way that makes them more economical to build, more repairable if they're devices that get reused in the field, and just overall improves the kind of the manufacturing with concurrent engineering. So long-winded answer to your question, but I think the key value proposition or differentiator for us is that balance between aerospace discipline and new space agility, and that's really driven by a core competency in concurrent engineering and manufacturability.
So who are your customers, and can you give examples on projects Applied Aerospace has been involved with?
Sure. Probably most of our customers are the major aerospace companies. And as I said, a lot of the new space companies are now becoming clients as well. Examples of specific programs in space and in aircraft. So in the aircraft world, we're on a number of fighter jets, trainer jets, as well as bombers, where we provide a lot of different components and structural elements for those aircraft. In fact, if you think about some of the early warning aircraft, you kind of picture in your mind aircraft that have big radomes kind of on the back, and we build that entire system. So the whole dome that goes on the back and the pylon that attaches to the top of the fuselage. So that's a good example in the aircraft space. In the launch vehicle industry, we build, as I said, the kind of the nose cones for two different crewed spacecraft. We build payload fairings for a variety of different commercial launch vehicles, and we build the telescopic legs that, or the actuators really that push the legs out for one of the major reusable medium launch lift vehicles. So those are all some good examples. Historically, the company has also built a lot of bus structures, core elements for large geosynchronous satellites in the communications arena, as well as scientific spacecraft that go well beyond Earth's sphere of influence deep into the solar system. So broad range of different types.
Aerospace recently acquired Nexol. What will this combined offering bring to the market?
It's a great question. When I was talking about our three different kind of lines of business or core operating areas, so we've got our main campus in Stockton, California. We have our innovative composites group up in White Salmon, Washington, and the Huntsville location near Marshall Space Flight Center actually came with the acquisition of Nexol. And they're really an amazing company. It's a group of really dedicated chemists and physicists and engineers who just love to solve difficult problems. They're really kind of two key elements of that business that really added some complementary capabilities to Applied Aerospace. The first one is they actually developed their own proprietary formulas for a variety of polymer materials, and these come in a powdered flake form, they come in a liquid resin form, but they predominantly use it in a film form factor that can then be stretched and shaped to be used for things like solar sails, things like sun shields, passive deorbit systems, a variety of different applications on low Earth orbit spacecraft as well as deep space scientific spacecraft. So the ability to build the raw material, if you will, that film, and then also build the deployable system that film is used on is a really unique capability that adds a lot to the overall Applied Aerospace portfolio.
So innovation is key. What does it take to be an innovative company in today's market?
I think first and foremost is listening to your customers. And as I mentioned earlier, we really pride ourselves on striking that balance between aerospace discipline and new space agility. And one of the examples of that is being able to hear what your customer wants, but also take a consultative approach to helping them make the product better. So for example, we'll have a customer that'll come to us and say, here's a drawing for a new spacecraft module. Can you make this for us? And we'll look at it and say, yep, we can do that. But if you're open to some design recommendations, this area that you have made out of forged aluminum, we think would be better if you made it out of bonded aluminum. This area over over here we think might be better suited to be a composite material. Changing how some of the pieces fit together improves the manufacturability of that product. And so I think it goes back to using our concurrent engineering core competency as a way to help our clients make the designs of their spacecraft or aircraft more effective, more efficient, reduce waste in the production and the manufacturing process, and where it makes sense, especially for reusable launch vehicles and aircraft, make them easier to maintain, easier to replace parts over a service life. I mean, one of the things that we do today, surprisingly, aircraft that you might think of that are kind of retired or still actively flown by the U.S. military, we build a lot of replacement wings and wing spars and stabilizers and various components that after so many cycles have to be replaced. And so helping our clients figure out how to do that in an effective way is a key part of our value proposition.
We do see a flourish of government from the government sector for business. What are your main opportunities in this domain for you, and how can you tap into these initiatives?
So I think from the space arena specifically, there's really two segments. So, you have the dramatic increase in launch vehicle launch rate, right? With companies like SpaceX now launching virtually on a weekly basis. And so that's driven not only by the mega constellations that are putting up, hundreds or even thousands of satellites in low Earth orbit, but also by a drive to sort of commercialize things that used to largely be done by government. So look at the Earth observation market, for example, right? You think of Earth observation satellites either for weather or for intelligence were dominated by nation-state space agencies. But now you've got a ton of companies out there that are offering it as a commercial service. Companies like Black Sky and Capella and Satellogic and many others. And, the opportunity there is that government is looking to buy that as a service, but that means our customers oftentimes become commercial entities. So we are providing systems, components, structures to the companies that are flying their own spacecraft, operating their own constellation. So it shifts the business model a little bit. At the same time, the Space Development Agency out of the U.S. Space Force is spending nearly $3 billion a year on new bus systems for a variety of different spacecraft, some that are intelligence, some that are communications, a variety of different missions. And so that's created a kind of a need almost to form a coalition of subsystem manufacturers to go after that market, because it's a different type of spacecraft, a different type of market, different type of manufacturing than the traditional large-scale geo satellites have been historically. So I think that's creating a lot of opportunity for smaller companies, smaller suppliers that maybe don't have as much history to get into the game. And at Applied Aerospace, as a company with a long heritage, we have an ability to help those companies come to market. We can be a partner. In some cases, we can be an outsourced manufacturer, contract manufacturer for them. We can help a lot of those newer companies really establish their foothold in the space market.
What's your take on the direction the market is heading?
It's an interesting time. As we all watch the news under the new administration, I think there's a lot of questions that are being raised. I think the fundamental truth, though, that will continue regardless of what happens from political influence is that there is this move towards the commercialization of space. The days of having nation state or DoD or NASA kinds of organizations dominate space strategy, I think are not going away completely. They'll continue to be a major driver of demand with public-private partnerships and funding for development contracts. That's going to continue to be the backbone of the U.S. space industry for sure. But I think the number and the variety of commercial companies that are going to be able to participate in commercial space is just really growing. And this is kind of, the space renaissance you hear everybody talk about. And we're excited at Applied Aerospace. I think we're able to bring a legacy, heritage, and just a manufacturing and engineering know-how that can really position ourselves to be a supplier of choice for that continuing to develop space renaissance.
And of course, you had some very impressive year-end results.
We did. We had a great year in 2024. We just closed our fiscal year. Third year in a row, the company has enjoyed double-digit growth. Fastest growing sectors for us are spacecraft and launch vehicles. It's a little less than half of our business today. We actually closed the year with over $450 million in backlog total contract value, which is a tremendous benchmark for for us. That came somewhat from growth on existing contracts, but really from 30 new contract awards just last year. So we're very excited with where the company is going, and I think we're well poised to make continued investments, primarily in acquisitions and in partnerships with companies that bring more technology and more capability to bear, so that we can really grow our share of vehicle, as we like to say, share of the launch vehicle, share of the spacecraft vehicle, in terms of the types of solutions that we can offer our clients.
David, thank you very much. We wish you every success.
Thank you very much, Kevin. I appreciate it.